Connor and I were thinking that, there's been like a lot of disagreements in the whole space, and we think that, it might be good to actually just go back to the Bitcoin white paper and actually do like a deep dive into each section here. So I think we're gonna like do a series of videos, and I think we might like even splice them up into each section as well. That way, people can kind of easily access each section. But like today, I think we're gonna try and get through the abstract up through section 3. Is that right, Connor?
Yep.
And so we're gonna try and break down each section. Read it, analyze it word by word. Well, not word by word, but, you kind of get the gist. But I think, we're really going to try and do a deep dive into Bitcoin white paper and what it actually means, because we kind of discussed it beforehand, and we feel like a lot of people often overlook the Bitcoin white paper. And to be honest, I don't think that many people are actually reading it and actually putting all of it together, because a lot of the problems that other blockchains face, I think a lot of the problems that other blockchains face were already solved in the Bitcoin solution, pretty much. And I think it's a lack of, I don't know, I don't think people really understand the white paper. So I think we're going to try and just do a deep dive into each section here in a more audio and visual way for people, because one thing for me is, like, I don't know, I have a hard time reading things sometimes, or reading them all the way through. So I think, trying to put it down in an audio podcast version, I think it might benefit a lot of people. What do you think, Connor?
Yeah. No, I mean, I think, most people haven't, we talk about this a lot. I go to blockchain kind of groups and stuff around town.
Mm-hmm.
I would be shocked if 80% of them have actually read this paper,
Mm-hmm.
And I think what we're going to cover today is if you kind of look at this at this white paper itself, it goes very well beyond this idea of like a blockchain. And if you actually, like, again, I'm sure you've seen this happen, but if you go to these meetups and stuff, it's always like, yeah, so Bitcoin introduced the idea of a blockchain, and so now here's like X, Y, and Z, which improve upon Bitcoin because blockchains can't scale and blah, blah, blah. But like, if you actually read this paper, it talks about like an entirely new cash system that goes well beyond just this idea of a chain of digital signatures, right? So, yeah, so I guess we're going to kick off part 1 of our white paper series with, again, talking through the abstract to sections 1 through 3. We're pretty excited about this. I think that it'll help, like you said, right? It'll kind of make this digestible for people who don't want to read, or if they even if they do want to read it, but maybe it's hard for them to understand pieces. We're going to try and just break it down to make it easy to understand. So
yeah, I've had a lot of people actually come to me and ask me if they're very introductory level to the system and Bitcoin and cryptography and blockchain. And they always kind of ask me, like, am I capable of reading the white paper right now? So I think even the white paper, it's a little intimidating to people as well, which I think, I don't think people should be intimidated by it. So hopefully we can break it down a little more simpler way.
Yeah.
So
you want to jump in?
Yeah.
All right.
Let's jump into this thing. All right.
First thing off the bat, I mean, isn't it weird? The title itself is already pretty contradictory from a lot of what you hear in the space. So if people that don't know, it's Bitcoin is a peer-to-peer electronic cash system. So off the bat, it is not a digital gold store value, peer-to-peer electronic cash system. It was written by Satoshi Nakamoto, unknown entity in the world. And we're going to start with just the abstracts. So we're going to kind of just read this, actually. I mean, I think it's important. Again, you can kind of treat this in an audiobook, whatever you want, but we're going to read through every word in the paper, but we're going to stop as we go along and kind of break it down. So I'll I'll start with the abstract. So the abstract, a purely peer-to-peer version of electronic cash would allow online payments to be sent directly from one party to another without going through a financial institution. Digital signatures provide part of the solution, but the main benefits are lost if a trusted third party is still required to prevent double spending. We propose a solution to the double spending problem using a peer-to-peer network. The network timestamps transactions by hashing them into an ongoing chain of hash-based proof of work, forming a record that cannot be changed without redoing the proof of work. The longest chain not only serves as proof of the sequence of events witnessed, but proof that it came from the largest pool of CPU power. As long as the majority of CPU power is controlled by nodes that are not cooperating to attack the network, they'll generate the longest chain and outpace attackers. The network itself requires minimal structure. Messages are broadcast on a best effort basis, and nodes can leave and rejoin the network at will, accepting the longest proof of work chain as proof of what happened while they were gone. So this, very, very clearly, I think, kind of defines the whole paper. It does actually a surprisingly great job of kind of touching on every little bit and piece that will come up. So I think like the main thing that I think sticks out to me based on what we just talked about is number one, right? We're describing a peer-to-peer cash system. So off the bat, we're saying this is supposed to be used as payments, as a payment system. Again, that off the bat, that's what it is. But also, it says here, digital signatures provide part of the solution, but the main benefits are lost if a trusted third party is still required to prevent double spending. So really, the blockchain itself is only part of the solution. You need some kind of system, and what we find out as we go through this is it's really the economic incentives of the system that prevent the double spending from occurring. So I think that's just very interesting. It's not talked about. Again, you go to these groups and they'll all try and lie to you. They'll say, blockchain, the big innovation of blockchain that Satoshi invented, which he didn't, by the way. But, that's the innovation. Forget everything else without even understanding that the economics of the system is really the innovation, right?
Right. And I think just at a high level too, what I kind of pull away from this abstract here is like, it's a high level summary of Bitcoin. And I think it establishes a problem that Bitcoin is trying to face. And I think, the problem is in current finance and today, especially in an online digital world, we currently have a problem of like legitimizing transactions without a third party and preventing fraud at a high rate. So, the solution here that Bitcoin offers is, that peer-to-peer network, that's time-stamping transactions by hashing them into the ongoing chain. But, that's the solution here to a current problem that we're facing today. And, it all kind of pulls it all together, like the economic incentives a little bit here at a high level too, how the longest chain not only serves as a proof of sequence, it's the largest pool of CPU power. So, it introduces the ideas of proof of work and how that secures the network. I don't want to get into proof of work too much yet, because that's a whole section in itself. But, this abstract does a really good job at a high level of explaining everything that Bitcoin is. And just another kind of key point I think here is that last sentence there, messages are broadcasted on a best effort basis. And to me, I think that kind of introduces the idea of Bitcoin being a small world network, which, small world network gets a lot of shit these days. But I think, that really is important, how these messages are broadcasted on a best effort basis. And what that is kind of inferring is that, these nodes have to be high connected, or there has to be high connectivity between the nodes to make sure that, these messages are being broadcasted efficiently. So it, this abstract does a pretty good job of explaining Bitcoin at a high level.
Yeah. And I think, to touch on, I think everything you said here pretty much covers it, but just because we are going to touch on it at the end, it's also spelled out pretty clearly in the abstract that the governance model itself, right? So the governance model is determined in the case of, so the blockchain itself, like you said, right? So it says here it provides part of the solution, but the main benefits are lost if you don't have something preventing this double spending problem. And the double spending problem itself can only be solved if you have an incentive model that fixes it. And so what happens if the incentives clash, right? What happens if you have like warring factions in the incentive model? It's spelled out pretty clearly here that the longest chain not only serves as the proof of the sequence of events witnessed, but proof that it came from the largest pool of CPU power. Again, we're going to touch on this a lot, but that longest chain piece is really the governance model of Bitcoin, right? So,
Yep.
So, the introduction here, this is pretty straightforward. So we'll kind of just we'll go through it, but I think we have some interesting kind of takes on why this is brought about in the introduction. So, kind of blow right through it. So commerce on the internet has come to rely almost exclusively on financial institutions serving as trusted third parties to process electronic payments. While the system works well enough for most transactions, it still suffers from the inherent weaknesses of the trust-based model. Completely non-reversible transactions are not really possible, since financial institutions cannot avoid mediating disputes. The cost of mediation increases transaction costs, limiting the minimum practical transaction size and cutting off the possibility for small, casual transactions. And there is a broader cost in the loss of the ability to make non-reversible payments for non-reversible services. With the possibility of reversal, the need for trust spreads. Merchants must be wary of their customers, hassling them for more information than they would otherwise need. A certain percentage of fraud is accepted as unavoidable. These costs and payment uncertainties can be avoided in person by using physical currency, but no mechanism exists to make payments over a communications channel without a trusted party. What is needed is an electronic payment system based on cryptographic proof instead of trust, allowing any two willing parties to transact directly with each other without the need for a trusted third party. Transactions that are computationally impractical to reverse would protect sellers from fraud, and routine escrow mechanisms could easily be implemented to protect buyers. In this paper, we propose a solution to the double spending problem using a peer-to-peer distributed timestamp server to generate computational proof of the chronological order of transactions. The system is secure as long as honest nodes collectively control more CPU power than any cooperating group of attacker nodes. So why here, right, Corey? What's your take immediately off the bat? Like why is the introduction?
Well, I have some interesting takes that I feel like often get confused in the community, and specifically in the first paragraph. The introduction, it introduces Bitcoin, and Bitcoin often gets confused with politics, I feel like, and political beliefs. And no matter what your political beliefs are, I think it's important here to say that, the Bitcoin introduced in this section is more about an efficient and trustworthy system of payments. There's really no talk of anarchy, libertarianism, I'm not saying that there's anything wrong with that and like being free staters, and I'm all for freedom and everything. But I think sometimes, especially when you start talking about Bitcoin as a religion and we have all these different tribes, I think we need to look at what Bitcoin really is. And I think what's introduced here, to me, this just seems like Satoshi Nakamoto is really just presenting an idea of a much, much significantly more efficient system of sending online payments and payments that you can trust too.
Yep. It's interesting, right? I mean, there's a lot of people that try and like really tie the, like you said, not that we're against or anything, but there's a lot of people that try and tie this like anti-state, anti-government thing to Bitcoin, but really there's nothing at all, like you're saying in the white paper, that makes it political. And in fact, it really is just saying, hey, we have a problem. payments on the internet are not, number one, they're not conducive to micropayments. Like like he says here, right? There's a minimum practical transaction size that can only exist across the internet or any communication medium, and it cuts off the possibility for small casual transactions. So, I mean, really, that's number one. One of the things talked about of solving, which again is interesting, right, Corey? Because again, if you take like the BTC side of things, of like, well, you should be, transaction costs aren't a bad thing. I mean, that really flies in the face of why Bitcoin was introduced. Like you're saying, I mean, Bitcoin wasn't introduced for this digital store value. Like, there's really nothing mentioned about fiat money in this. There's really nothing mentioned about, like, it's really just, we need a peer-to-peer cash system that's frictionless and that like you said, it's trustworthy, but it's trustless, right? I mean, you can trust the system, you can trust the network, but yet you're not relying on a quote unquote trusted third party.
Right. And I mean, it even says, like, in there too, a certain percentage of fraud is accepted as unavoidable.
Yep.
And like, it's almost like, why should that be unavoidable? Like, why should we accept a certain level amount of fraud, especially in like a digital world that we live in today? The next sentence kind of talks about how, like, cost and payment uncertainties can be avoided in person by using a physical currency. But physical currency in today's world just isn't going to work.
Yep.
It's not going to work anymore, especially in an online digital market. So yeah, I mean, Bitcoin really is just an efficient, trustworthy system of payments. I mean, the problem is merchants want to guarantee that they're going to be they're guaranteed payment.
Yep.
And the solution today that we have, and the problem that I think this white paper's establishing is that this third-party verification system has to gain so much information about the buyers, up to a point where it's like, well, that's a little too much information, because now you're putting the buyers at risk of giving too much information, letting their identities getting hacked. So that's the problem that we're trying to solve. And using cryptography and this solution, it blows my mind. It really is amazing.
What's interesting? It's a little off topic, but I was actually listening to a conversation on the Bill Simmons podcast. Bill Simmons, and this was actually back in 2009, and which is very actually ironic. It was in 2009.
Yeah.
And the whole thing was talking about how at the time there was a writer's strike in Hollywood. And I know this is a little off topic, but it very much ties into, like, why are we here, right? Like, why are we doing this? And and the writer's strike at the time in the United States around Hollywood is about, like, well, writers were upset that they were worried that studios were making money on the internet that they weren't getting a cut of. And the whole conversation kind of wrapped around the idea that, like, well, number one, no one was figuring out how to make money on the internet at the time. And then, like, number two, there's a whole conversation they had about, like, well, if I want to buy something, it's a big pain. I have to put in my information, my credit card information, my shipping information, just to make a payment, right? I think, and it was just interesting listening to that conversation, and then, like, nothing has really changed today. Like for us it has, because we are in this, like, Bitcoin world, and you kind of can understand, like we've used the money button. We've used, like, these things that are coming out that it's just like, oh, click a button, money is sent. I don't have to put in my information or anything like that. But but it's just interesting to me that I was listening to that literally today. I was like, nothing has changed. Like the ability to go on the New York Times and buy an article, like, that doesn't exist, right? You're paying for subscriptions. You're putting in all this information. So,
right.
But one of the things I want to talk about, sorry, I know it's a little off topic, but I just think it's interesting. Like, these things are still a problem, like 10 years removed from this paper. And it's because we've been talking about all these, like, non-issues, like the scaling problem. But, like, it says here, transactions that are computationally impractical to reverse would protect sellers from fraud, and routine escrow mechanisms could easily be implemented to protect buyers. Where is that today?
Exactly. And this is, yeah. I mean, we've been wasting our time talking about block size, where I think we have the solution for the sellers, making it computational impractical to reverse transactions. We have that.
Yep.
And this is what Bitcoin solves for the merchants. Now, the problem ends up being is the buyers, to make sure that they're going to get, because obviously, Bitcoin solves the problem of the payment. The merchants get Bitcoin. They get the electronic peer-to-peer cash system right away. The problem is now for the buyers to make sure that they can get their products that they're getting. And specifically, Satoshi Nakamoto says right here, routine escrow mechanisms could easily be implemented to protect buyers. Now, Bitcoin was not the routine escrow mechanism that could easily be implemented. I think that Satoshi Nakamoto knew that this could already be done.
Yep.
Especially in a system of law. Where a merchant legally has an obligation to provide that service, given that payment. So it is frustrating to see that on the Bitcoin white paper today, and we're sitting here in 2018 when Bitcoin was designed back in 2009, and we're sitting here talking about block size.
Yep.
Block size? Block size? We're sitting here talking about block size? But really, it's...
Well, in the original code, there was a marketplace. There was a marketplace in the original code. And to be honest with you, like, nothing really has been done on that front. Yeah. But, so it's interesting. So...
Not, and I'm not saying that people aren't working on this now.
Right.
I'm not saying that. I think people are working on this now. I think finally that we've gotten over that hump. I think we're going to start seeing these routine escrow mechanisms. I think we're going to start seeing them being implemented. But that was something to me that really stood out, and it stood out to you as well. That they're not there.
Well, and I think and not to like beat the dead horse, but again, we're sitting here talking about Bitcoin as money, as cash. And I think like that philosophy has been so far removed from Bitcoin for years now. And so I think that's kind of the purpose. Like we're here and it's like, well, someone's got to start thinking about Bitcoin as cash again. So hopefully this helps people like really come back and think about this and be like, oh wait, maybe what I would say about this, there's money to be made. There's money to be made for people building these solutions like that. Again, we're 10 years removed and they're not really built yet. And like, again, like all props to $5, right? This is a marketplace. This is the kind of stuff that needs to be built. So anyway.
Right.
So.
And we've talked a little bit too on our shows before where we talk about merchant making sure that they get paid, and some, if they're using a POS system that offers some type of insurance of a double spend. Yep. There's money to be made there as well. Exactly. And that's one of these escrow mechanisms that we're kind of talking about.
Yep. Well said.
So, boom. Yeah. All right. I think that covers the introduction.
Yep. Perfect. So.
All right. You want me to read this one?
Yeah, you got it.
Take a little break.
Yeah.
Maybe sit back, enjoy a nice cold brew.
I'll pop it
up. So section number 2, transactions. All right. We define an electric coin as a chain of digital signatures. Each owner transfers the coin to the next by digitally signing a hash of the previous transaction and the public key of the next owner and adding these to the end of the coin. A payee can verify the signatures to verify the chain of ownership. The problem, of course, is the payee can't verify that one of the owners did not double spend the coin. A common solution is to introduce a trusted central authority or mint that checks every transaction for double spending. After each transaction, the coin must be returned to the mint to issue a new coin, and only coins issued directly from the mint are trusted not to be double spent. The problem with this solution is that the fate of the entire money system depends on the company running the mint, with every transaction having to go through them just like a bank. We need a way for the payee to know that the previous owners did not sign any earlier transactions. For our purposes, the earliest transaction is the one that counts. So we don't care about later attempts to double spend. The only way to confirm the absence of a transaction is to be aware of all the transactions. In the mint-based model, the mint was aware of all transactions and decided which arrived first. To accomplish this without a trusted party, transactions must be publicly announced, and we need a system for participants to agree on a single history of the order in which they were received. The payee needs proof that at the time of each transaction, the majority of nodes agreed it was first received.
So should we, let's, before we even dive in, I think we should explain this image to help people, anyone, because again, I think it's easy for us to be like, well, this all, like, you've used Bitcoin, this makes sense. But for anyone who like hasn't used it, like, this image probably does not help clarify it at all.
Yeah. Well, I think just first to start off bat, like, I think people kind of get confused with like electric coin, thinking of it as like a coin, like a nickel or a penny or some kind of like physical thing. And I think once you get over the hump of saying that, like, that an electric coin is actually just a chain of digital signatures of ownership.
Right.
So it's pretty much almost like a piece of paper that continuously signs away ownership to another person.
Yep.
So yeah, I just want to make sure that, because for me, when I first heard about Bitcoin, I thought of it as like, you know, this single thing. I think when you start thinking of it in terms of a chain of digital signatures of ownership, I think that's when it starts to all come together and like how the verification process works.
When I think like, right, if you abstract away from physical money to just like electronic money, which is what we have today. I mean, right. I mean, for the most part, we use digital bank accounts and that kind of stuff. If I were to send you from my bank account to your account $5, the ownership just gets signed from me, the $5 sent to you, right? And
yeah,
that's just digital information. But so, but the beauty really of Bitcoin is that using cryptography, you can actually verify that ledger, right, throughout the coin, or and in this case, the coin's history. So to kind of just explain this image here, you can think of a hash just as a unique cryptographic identity of a file, of text, of anything, of any kind of digital good. Whether that's like any digital file can be hashed, where you have a unique identifier that points to that digital file. So in the case of like Corey, let's say you're owner 0 in this image, right? And you want to send me Bitcoin. Okay. So basically what you would do is, well, that's actually not a good example. Let's say just in general, you're owner 1. Let's say you have Bitcoin, owner 0 sent you Bitcoin via a hash. Okay. They sent you this cryptographic proof that the Bitcoin exists, and they relinquished ownership to you with their signature here. So now you, owner 1, have what's called a public key, which public key is just an address. So if you want to make a Bitcoin transaction as defined here in this white paper, what you would do is you would say, okay, Connor, I'm going to send this to owner 2, you. You would sign with your private key, which is just like a password, and you'd sign and verify the transaction, which would alter this hash and form a new hash. And now owner 2, me, owns it, and then I can continue that as far as I want. But the beauty of this is that because, you know, just look into cryptography, what you can understand is that you can actually work backwards through this and verify ownership over time. So that's really the root of what this transaction system is getting at. And it really is just a cryptographic concept, right? So if we move forward from that, I think what gets kind of interesting is that, like, really what the white paper here outlines is, well, today we rely on mints. We rely on these trusted third parties, trusted central authorities, really. Like, this is like probably where it gets the most political here, because the mint itself in today's society is government, right? So like in our case, it's the U.S. government, where really they mint the currency. And even though, like, if I use my Visa credit card, Visa acts as that trusted third party to say whether or not my transaction is valid. on the root level, right? Like the U.S. government is who tells Visa your transactions are valid because you're using real U.S. dollar, right?
Right.
So in a way, what we do is really built on layers of of trusted third parties, right?
Yeah.
Which is kind of scary on its own, right? But so I think you can jump in, but really I think what this says here on a high level is just that in the mint based model, the mint is the one who's kind of deciding what transactions are valid and which ones count, and then
well, it's almost not the transactions, it's they're verifying that the coin or the note that's being used to transfer wealth is valid.
Yes.
So it's not necessarily the transaction, but it's more like legitimized liquidity that is being transferred over to another owner.
Yep.
Which I think, and the problem that I have with, allowing something like a third party do this is that they can then create new promissory notes at their will.
Exactly.
And that's the problem that I think a lot of currencies have today, especially in the fiat world, is, this threat of hyperinflation. So that's kind of another thing that Bitcoin's trying to solve, is they're trying to control the level of inflation as well. Because the price of Bitcoin is very volatile, and it can skyrocket up. But the rate at which more Bitcoin is being created, that's a relatively stable amount. And the halvings that we have, that process comes through proof of work. And
it's interesting that we haven't even gotten to the idea of the deflationary cap, right? The cap itself hasn't even been identified here in the white paper.
Yeah.
I mean, really, all we're talking about is like, it talks about the mint based model where but really, in all this section is saying is the mint is the one who decides on which transactions are valid, and so again, it's interesting, these concepts of like, really just looking at the white paper here so far, all we're talking about is how do we solve this double spending problem, right? But you're right. You're completely right that Bitcoin obviously does solve the minting problem itself, right? Right. So the only thing I wanted to mention here is that like the small world stuff itself actually becomes noticeable, because it's saying here that in order to even accomplish this, the transactions must be publicly announced, and you need a system where the participants in the network agree on a single history, and really that's done because the announcement is you're incentivized to do that announcement,
right,
and obviously then the payee themselves needs a easy way to ping the majority of nodes to figure out when it was first received. So we'll talk about that a lot more in the future, but obviously that's interesting right there. So
yeah, and I think too, like just talking about an efficient system that we have now too. I don't want to harp too much on this example, but like if we're actually using like physical currency, try and relate Bitcoin to a physical currency of what's actually going on. It's almost like taking a US dollar bill and then going into a store, and you're within that mint, you are the owner of that US dollar bill. And when you make that payment to the store, the merchant, you're signing away on the dollar bill that, maybe the merchant now owns that dollar bill because you're paying them for this transaction. Now the problem is the next time that US dollar bill is used somewhere else, someone wants to make sure that that's a legit US dollar bill. Now, in that system of using a physical currency, that merchant has to let the US government know that they now have ownership of that coin. And not only do they need to verify that, but the person, like me, going into the store, I need to verify that I transferred that over. So now in Bitcoin, that almost gets, in a digital world of Bitcoin, that broadcasting of that transfer of ownership is almost like automated now.
Exactly.
You know?
Exactly.
So it's all about really just that much more efficient system.
Yep.
So yeah, not to harp too much on that, but
no, yeah, well said. So this section 3 is brief, but it's the meat and guts of what you hear in the space today. So we'll cover it and talk about it. So section 3 is called timestamp server. So the solution to everything we're talking about here, so the solution we propose begins with a timestamp server. A timestamp server works by taking a hash of a block of items to be timestamped and widely publishing the hash, such as in a newspaper or Usenet post. The timestamp proves that the data must have existed at the time, obviously, in order to get into the hash. Each timestamp includes the previous timestamp in its hash, forming a chain with each additional timestamp reinforcing the ones before it. So we have infamously the quote-unquote first time you ever hear of a blockchain. Because that's blockchain. So if you actually look at the history, Satoshi Nakamoto was not the first to talk about a blockchain. A chain of digital signatures was very widely talked about since like 2001, I believe. But really what you're looking at here is the modern day description of a blockchain. Now what's interesting is we have about 9 more sections to go. So if you go again to these blockchain cryptocurrency meetups and stuff, they'll really try and tell you that Bitcoin's innovation stops here. They'll say, well, Satoshi invented the blockchain, but now here's my shilly project that fixes what Satoshi couldn't figure out. And that's because they never, ever even understood proof of work. They never understood how the network operates. They never understood the incentive model behind it. They never understood how SPV would work. Really, it's insane to me that this is something no one understood. And we're going to get into it. We're covering the whole white paper. We're going to make sure everyone actually understands this stuff. But here it is. Here's the blockchain. So we'll cover this real quick in depth. Really what this is describing is, all those transactions that we mentioned up here. Let's just say that this all occurs in about 10 minutes. We can take all of this right here, take a hash of it, again, a unique cryptographic identifier, and publish the hash to the entire network. And then the entire network would then, maybe in another 10 minutes, find all the other transactions that occur, publish a hash of it, and build on top of the previous hash. And basically what you have here is just a blockchain. You have an immutable ledger of digital signatures that reliably has a history that's very hard to change.
And I think it's important to know that it's immutable, or like you said, it's really hard to change.
Yep.
And like for someone to change it, they theoretically have to do all of the work that was previously done to change it, and then that's what kind of in the abstract, I think it said something about outpacing, trying to outpace the honest chain. Well, if you have to redo all the work that was previously done while keeping up with the current workers that are building on top of the honest chain,
yep.
That's where the immutability starts to come in, I think, a little. And, that's where it starts to be secure and efficient.
Yeah, absolutely. So here we have it. Really, this is, what's amazing to me is what we've just covered is already, honestly, what we've just covered is the introduction to blockchain that you will get. Again, the whole blockchain thing just pisses me off. It's just like, that's the craze right now. And I'm surrounded by it in my city. I'm surrounded by these people that just really think that that's the new thing, but it's not. Again, it only took Satoshi 3 sections to get through these concepts, and what we'll go into in very much in depth in the next sections that Satoshi really built an economic system that solves these problems. So again, if we come back to the introduction, or maybe the abstract, digital signatures provide part of the solution. Really, the solution to prevent double spending is all in the economics, which Satoshi built on top of Adam Back's Hashcash, improved it. So
it is kind of ironic too how we talk about a blockchain, how everyone's like, yeah, Bitcoin, I don't know, but blockchain,
exactly.
I think that was the revolutionary tech. And if you actually look at like the whole white paper in this section here, the section here is like one of the smaller ones.
Yep.
It's but people seem to hone in on that, and they might just be a little jelly that they didn't come up with Bitcoin themselves, so they're trying to create their own Bitcoin now.
Yep, absolutely. All right, so we'll conclude. This is section 1 of our white paper series. Or part 1.
Yeah.
We plan to have probably 4 parts. So this is 1 through 3. We'll get through all 12 parts. So or 12 sections. So
yeah, I'm looking forward to the next one too.
Yeah,
about proof of work.
Proof of work, the network, and incentives. Really the meat and guts of where everything went wrong with BTC, I think. But